Welcome back to the deep dive. This is where we take your pile of sources,
Yeah.
articles, research, maybe some notes we've scribbled down, and really try to pull out the key insights.
Yeah, that's at the core of it.
Exactly. And today, we're diving into something, well, it's a really big claim about the future of AI, something that could potentially unlock trillions in value. Trillions.
Yeah.
But only if we can crack this one fundamental problem. It's something people don't always talk about.
Right. And that problem, it really just boils down to trust. You see the headlines, McKinsey saying AI could generate, what, $13 trillion by 2030?
A staggering number.
It is. But then you hear reports, something like 85% of AI projects actually fail.
85%. Wow. Why so high?
Well, because companies are like renting intelligence. They're using these powerful models, but they don't fully control them. They can't really verify them deeply. And here's the kicker. They can't insure them.
Okay, so it's like having this amazing tool you can't actually use safely.
Exactly. Imagine renting a Ferrari, but you can't get insurance, so it just sits there. You need that real ownership, that control over the decision-making. They call it sovereignty. Without it, that 13 trillion, it stays locked up.
So that's our mission for this deep dive. We've got sources here, including a pitch deck from this company, Theta Driven, and also a pretty dense patent application they filed.
Right, quite technical.
And they're claiming they hold the key to unlock that 13 trillion. They've even called what they've built the Black-Scholes of AI.
A very bold comparison.
It is. So we need to unpack what that actually means, how they think they can do it, and maybe most importantly, what it could mean for you, for how you understand and maybe even use information going forward.
Let's dig in.
Okay, so when we talk about this $13 trillion lock, this value that's just sitting there, what's the absolute core issue with AI right now that's stopping it?
Well, like I said, the current state often feels like a rental car model. Think about it. You take a big model, maybe GPT-4, maybe Claude, and you fine-tune it.
Right. You customize it for your needs.
Yeah, but the engine itself, the fundamental reasoning, that's still ultimately controlled by OpenAI or Anthropic or whoever built the base model. You're building your house on rented land, essentially.
Okay. I see the problem.
And that leads directly to this huge hurdle, insurance. No insurance company wants to touch a deployed AI system if the risk is, well, unbounded, infinite, potentially.
Because you can't fully predict or control it.
Exactly. Theta Driven, they're hearing this directly from companies, people asking, how do we insure our AI? You have boards demanding, look, show us the boundaries, put limits on this thing, or we have to shut it down.
Wow. There's a real operational roadblock.
It absolutely is. This lack of verifiable control, it just makes the risk profile too high for deploying AI at the scale needed to unlock that 13 trillion. It stays locked.
Okay, that makes sense. So that brings us to Theta Driven's proposed solution. It sounds pretty audacious.
Yeah.
A Fractal Identity Map, or FMIR. And they're positioning it, as we said, as the Black-Scholes of AI. How does this mathematical model, how does it even begin to tackle such a huge, sprawling problem?
Well, the comparison to Black-Scholes is actually quite useful, I think. Remember, Black-Scholes gave the financial world a mathematical framework to press volatility. Suddenly, options became tradable in a reliable way.
Right, and that market exploded.
Exploded. From millions to trillions. AMA aims to do something analogous for AI. It's designed to provide clear mathematical boundaries for an AI's competence.
Okay, boundaries. What does that mean practically?
It means defining with mathematical precision what an AI can do and, just as importantly, what it cannot do within certain conditions. This makes its capability verifiable.
And if it's verifiable,
Then it becomes insurable, exactly. This concept lets them create what they call competence pixels. Think of them as tiny, tradable, mathematically guaranteed promises about specific AI behaviors.
competence pixels. Interesting term. But looking at the patent, it seems to go even deeper. It suggests Femnium actually defies decades of computer science thinking. What's this revolutionary idea about a beating heart in their system?
Yes. This is where it gets really mind-bending, actually. And yeah, it absolutely challenges some core beliefs held in computer science for, gosh, over 50 years.
What belief is that?
The fundamental rule, taught in basically every database textbook, is that you must strictly separate the logical organization of your data, how it's structured conceptually, from its physical storage, where the bits actually sit on the disk.
Okay, that sounds standard. Logic separate from physical.
It is standard, it's orthodoxy. But Theta Driven's invention, this algorithm they call consistent weight block rank, it deliberately violates that rule.
It violates it. How?
It unifies them. The physical data blocks and the logical hierarchy nodes, they're governed by a single, consistent weight-based rule. They call this the beating heart of the system.
A beating heart, meaning it's dynamic?
Exactly. Imagine this. As the meaning or the importance of data changes over time, the system dynamically and physically reorganizes itself on the storage medium for optimal access. It's like a living library where the shelves physically rearrange themselves based on which books are most relevant right now.
Whoa, okay, that's a different way of thinking about data.
Totally different. And this unification, this beating heart, it's not just about making things faster in a simple way. They claim it leads to these emergent properties, things like the system inherently staying coherent and self-optimizing no matter how big it gets. It completely changes the rules for storing and finding information.
A self-organizing living data structure.
Yeah.
It's hard to get your head around. But okay, if they're really breaking these established rules, what are the actual, like, measurable benefits? The numbers I saw in the sources were kind of eye-popping.
They are, and that's because this isn't just, tweaking an existing method for a small gain. They argue it's a multiplicative improvement, not just additive.
Multiplicative, meaning things compound.
Right. Because the system is always organizing itself based on meaning and relationships, it avoids huge amounts of wasted work compared to traditional methods that just search through everything blindly. So the numbers they claim, for instance, an 847 times reduction in the search space needed.
847x.
Okay, a 762 times reduction in memory access, how often it has to fetch data.
Also huge.
And maybe the most staggering, a 55,294 times improvement in power efficiency compared to traditional indexing.
55,000 times. That seems almost unbelievable. That comes just from this architectural change.
That's the claim. It stems from fundamentally rethinking how data is stored and accessed, linking it directly to meaning and relevance via this weight-based system.
Those numbers are definitely game-changing if they hold up. But there was one specific claim in the patent that really jumped out at me, this OE miracle. Can you break that down? What does OE mean for someone like our listeners just trying to manage huge amounts of information?
Yeah, the OE miracle, it sounds dramatic, but it's actually a really critical point for anyone drowning in data, which is, let's face it, most of us.
Tell me about it.
So first, what's E? In their system, E isn't the total amount of data, which is what usually slows things down in computer science. It's often N. Instead, E relates to how deep a piece of information is within their structure. Think of it like how many clicks you need to get to a specific file in a nested folder system.
Okay, so it's about the path length, not the total size.
Exactly. And the OE miracle claim is that the cost of explainability, understanding why the system made a decision or why a certain piece of information is relevant, is proportional only to E. It's essentially constant time relative to the total data volume.
Wait, so understanding why something happened in a system with 1 billion pieces of data takes the same effort as in a system with just 1,000 pieces, assuming the depth is similar.
That's precisely the claim. They say a 1 billion node system rebalances itself and explains its reasoning just as fast as a 1,000 node system.
Okay, that's profound.
It really is. Think about trying to find one specific clue in a gigantic library. Normally, the bigger the library, the longer it takes. They're saying the effort only depends on how many sections deep that clue is hidden, not the total number of books.
Right, and the constant time explainability.
Yeah.
That sounds crucial for the insurance angle you mentioned.
That's absolutely fundamental. You need that constant time interpretability to audit AI decisions reliably and make them insurable. It's potentially a massive game changer for just navigating information overload in general.
Okay, so we have this radical new architecture, the beating heart, these incredible efficiency gains, and this OE explainability. How does all that technical stuff actually translate into, real-world value? How does it unlock that market and create AI insurance?
It all comes back to making the AI's behavior predictable and, crucially, auditable. Because film creates those mathematical boundaries we talked about.
The competence pixels.
Right. These aren't vague guidelines. They're incredibly specific, mathematically defined promises. For example, you could have a pixel for a credit.risk assessment AI. That pixel might guarantee mathematically that the AI will only approve a loan if its internal confidence score is above, say, 0.95. And maybe it includes a defined drift tolerance, like its performance won't change by more than 0.01% per month.
Wow, that's specific.
Yes. And because those boundaries are mathematical and verifiable through the system's OE properties, an insurance company can look at that pixel and price the risk precisely.
Like pricing risk for anything else with known parameters.
Exactly. And here's the clever part. If the AI in operation somehow drifts outside that mathematically insured boundary, maybe its confidence calculation changes unexpectedly, it automatically triggers an insurance claim.
Ah, so it's self-monitoring based on these mathematical promises, like a black box recorder combined with an insurance policy.
That's a good way to think about it. The boundaries are the policy limits, and the system itself reports if they're breached.
And that is the foundation for this potential trillion-dollar market they're talking about.
Precisely. These competence pixels, because they represent a bounded, verifiable, insurable unit of AI capability, they can theoretically be owned, licensed, traded, insured, just like other assets.
Okay, so Theta Driven isn't planning to build all the AI themselves.
No, their model, according to the pitch deck, is primarily based on patent licensing. Think about how companies like MPEG license core video compression technology that everyone uses.
Right, they provide the underlying standard.
Theta Driven seems to envision doing something similar for AI trust and insurance. They want to provide the fundamental rails based on M and these competence pixels.
And how do they see the revenue working?
They estimate taking a small percentage, maybe 0.1% to 1%, of every AI insurance transaction that uses their underlying FEM structure. If the AI insurance market grows, and they project it could hit maybe $26 billion annually by 2030, which is just a conservative 2% of the potentially insurable AI value.
Which was 13 trillion.
Right. So even that small slice of the insurance premiums could generate, they estimate, maybe $1.3 billion in annual licensing revenue for them. That's how they argue they can control the rails for a potential trillion-dollar market overall.
And they're hearing demand for this.
They report direct quotes from enterprise leaders, people saying things like, "We'll pay anything for ownership," meaning that verifiable control and sovereignty over AI decision-making. That's the pain point they're targeting.
Okay, we've definitely covered some mind-bending visionary stuff here. This whole trillion-dollar market built on AI insurance and competence pixels.
Yeah.
But data-driven is, as the sources say, post-beta, pre-seed, very early stage.
Very early, yes.
So the natural question for you, the listener, might be, how on earth does a company at this stage even start to prove a concept this monumental? How do they show it works right now, today?
That's a fair question. And their approach, what they call phase one, is interesting. It involves a consumer-facing app.
A consumer app. That seems like a detour from enterprise AI insurance.
It might seem that way, but you have to understand it as a strategic proving ground. It's not really about building a huge consumer app business in itself, at least not initially. It's about validating the core FIM technology in the real world.
Okay, so what does this app do?
It uses what they call strategic nudges. These are delivered via short 30-second unrobocalls, not annoying spam, but targeted messages.
On robocalls. Okay, what's the goal?
The goal is to offer the user one blind spot bullseye daily. Basically, a single precise insight aimed at helping that user identify something they're missing and make progress faster in some area of their life or work.
A daily insight based on FIMM analyzing the user situation.
Presumably, yes. The details are a bit light, but the core idea is that this initial phase, even though it looks like a consumer coaching app, is strategically designed to demonstrate FEM's capability. Can it map reality effectively? Can it identify genuine blind spots? Can it deliver precise, useful insights?
And the data from this validates the tech.
Exactly. Every interaction, every bullseye delivered and rated by the user helps refine the mathematical boundaries within FEM. It generates real-world data showing whether the system can accurately model and predict complex human situations, which is essential groundwork for the future enterprise and financial applications we've been discussing.
So the consumer app isn't the product. It's more like the test bed for the underlying FEM engine.
Precisely. You can see this in their business model for the app, too. They explicitly state, "Your success is our product, not your attention."
That's counter to most consumer apps.
Right. They're incentivized for the nudges to be correct and useful, not just addictive or attention-grabbing. They even say if a nudge gets rated below a certain satisfaction score, 7 out of 90, seems like an odd scale, but okay, they give the user $5 credit.
Huh. So they pay if they're wrong.
Yeah. It puts their money where their mouth is regarding accuracy. It's a direct way to validate FEM's ability to deliver genuinely useful intelligence. And that core capability, that's what they believe, scales up to tackling those bigger enterprise problems and enabling AI insurance.
Wow. Okay, what a fascinating deep dive this has been. We've really gone from this huge $13 trillion AI potential,
Locked potential.
right, down to the nitty-gritty of why it's locked, trust, and insurability. and then explored Theta Driven's really audacious claim to have the key with their fractal identity map.
Yeah, from that beating heart idea that kind of flips computer science dogma on its head.
Right, unifying the logical and physical data layers.
All the way to these potentially insurable competence pixels built on mathematical proof. The implications, if it works, are genuinely vast.
It really makes you think. This idea that eventually every significant AI system might need insurance to operate in the real world.
Much like every car needs insurance to legally drive on the road, it could become a fundamental requirement.
Yeah. And this deep dive really shows how a breakthrough in like the foundational plumbing, the core technology of how information is structured and verified, could ripple outwards to create entirely new markets.
Absolutely. And transform how we interact with intelligence overall, whether it's human or artificial. Building that trust layer seems critical.
So for you, our listener, maybe here's something to think about. If a system, like FEM claims, can achieve these massive efficiencies, 800 times faster search, 55,000 times more power efficient just by breaking long-held rules about data.
Rules we just assumed were the only way.
Exactly. What other fundamental assumptions or rules about information, about knowledge, about how we structure things in our own fields? What rules are we following simply because that's how it's always been done?
That's a great question. What ingrained habits might actually be holding us back from really big breakthroughs?
Yeah. What are the blind spots, maybe, that we've forgotten to even look for in our own thinking? The STEM system offers that OE explainability, that promise of a constant bounded way to understand why something is the way it is, no matter how complex the system gets.
Getting clarity regardless of scale.
Right. And maybe that's the ultimate goal here. Not just accumulating more and more information, but finding ways to achieve a clearer, deeper, maybe even mathematically verifiable understanding of it all.